aluminium rolling mill plant will be located in the designated industrial area, which is approximately 10 kilometers inland from the Sohar Industrial Port Complex. The site selected is approximately 18 hectares. The project consists of building a turnkey greenfield casting and rolling plant adjacent to the existing Sohar aluminium smelter at Sohar. The plant will produce 140,000 tons a year of hot and cold rolled coils of various gauges and widths. The total covered area is about 35,000 square meters. Total installed power is 40 megawatt amperes. The tapping vehicles are coming from the smelter on 13-ton capacity crucible of liquid aluminium metal. Driving along the hot metal road entering the building to download the aluminium in the furnaces. The layout of the cast house is characterized by a back-to-back configuration of the furnaces. The cast house is composed of 4 melting holding furnaces with 70-ton capacity with cycles that produce 51 tons per hour stream of continuous liquid aluminium cast. Each furnace is subject to a production cycle having the following phases: material charging, liquid and solid; furnaces preparation, alloying and metal treatment. The tilting of the furnaces will allow the metal to flow through the launder to the caster. To achieve the required quality at the caster, the molten metal is degassed and filtered along the line. Liquid metal is fed from the caster tundish between the 2 caster belts and solidifies in a continuous strip of metal. The sheet thickness will be either 16 millimeters or 19 millimeters, with maximum cast width of 2,032 millimeters and nominal casting rate of 51 tons per hour. Downstream, the caster pinch roll, the aluminium strip, generates a natural loop that by gravity feeds the entry pinch roll of the hot rolling mill. The movable shear is able to cut the strip and prepare the head for an easy threading into the mill stand. After the cut, the head of the strip is introduced into the rolls where the mill is ready for rolling and therefore reducing the strip thickness. The strip is reduced as it is entering the second stand for a further thickness reduction. Between the 2 stands, a looper roll is controlling the interstand tension. At the exit of the second stand, the thickness and profile of the strip is measured using 2 X-ray gauges. When necessary, the edges of the strip can be trimmed during rolling to take out the edges defects or cracks. At the end of the coil, without stopping the casting and rolling process, the strip is divided using a flying shear to separate tail and head, and immediately a new coil is started, winding on the second down coiler mandrel. When a coil is completed, it is immediately transferred to a weighing and banding station, ready to be removed by the overhead crane. Coils coming from the hot rolling mill, stored into the storage bay, are taken by the overhead crane and loaded at the entry side of the CRM using a pallet conveyor system. Every coil is transferred to the preparation station, where the head of the strip can be flattened and removed. The coil is then transferred and loaded on the payoff reel mandrel, ready for threading and feeding the CRM stand. The rolled strip at the exit will be wrapped on the rewinder reel mandrel after thickness reduction. The complete coil is extracted from the exit mandrel with a pallet, transferred to the pallet conveyor and ready for a second rolling pass or transfer to the inspection station at the exit of the line. After the inspection, the coil will be banded and unloaded using the automatic overhead crane and transferred to the coil storage area or moved to the annealing area. The charging machine picks up the loaded pallets and transports them into the furnaces where the heating cycle starts. In the annealing furnaces bay, 3 single coil furnaces and a 3/4 coils furnace are housed. Coils are annealed several times at intermediate steps, following cold rolling and forming. When annealing cycle is finished, the charging machine picks up the pallets and comes back to the loading station. From the loading station, coils are transported to the storage area when they are cooled down to 70 degrees centigrade prior to further processing. Coils to be tension leveled, coming from the cold storage bay, are loaded at the entry section of the tension leveler by the overhead crane. A coil car is loading the coil on the payoff reel, and the line is starting operation to increase the quality of the strip using a tension amplifier with flattening cassettes to obtain a high quality strip surface and flatness. The line includes a visual inspection section and the possibility to center slit the coils in 2 halves. At the exit, the coil is rewound on the mandrel and unloaded by the exit coil car to the saddles, ready to be removed by the overhead crane. The slitting machine receives cold rolled coils from the storage by a 25 tons crane. The slitting line unwinds the coils, coats the strips on both sides, if required, and then simultaneously trims each strip. The slitting line slits the coils into narrower widths and rewinds them to suit the product mix. The finished product is packed and loaded on trucks to be transported to other facilities where they will be further processed. The finished product will be distributed in various sizes and different alloys according to the final use as listed below. Hot band, fin stock, HHF stock, AC duct, farmer and lidding, semi-rigid container. Industrial narrow light, industrial wide light, industrial wide heavy. From the above products, the following goods will be manufactured: household foil, food packaging, Pharmaceutical packaging, semi-rigid container. OARC, latest state-of-the-art technology in aluminium strip casting, rolling and finishing.